Process technology. Unit 14. Hazards and safety in the process industry. Outline. Chemical hazards. Physical hazards involving liquids. Electrical hazards. Explosions and fires. Equipment failures. Hazards associated with machinery. Corrosion and erosion hazards. Process hazard analysis. The main hazards of the process industries arise from the escape of process materials which may be dangerous, for example, flammable or toxic, or present at high pressure and high or low temperatures. Large and sudden escapes may cause explosions, toxic clouds and pollutions whose effects extend far beyond the work's perimeter. To prevent repetition of past disasters, diagnosis and exposure of the relevant hazards is essential. Safety in the process industry cannot be treated as a separate subject like design, production or maintenance. It is inextricably interwoven into these and other activities. Safety depends on both the technical competence and safety awareness of all staff and employees. Chemical hazards. A chemical hazard is any substance that can potentially cause physical and health hazards to people or the environment. A chemical hazard can also be defined as the actual risk associated with specific chemicals, such as skin burns, long-term negative impact to health, lasting environmental damage, fires, or even explosions. Types of chemical hazards. Although there are several types of chemical hazards that have been generally identified, the following are the chemicals commonly found in the workplace. Health hazard. Flammable. Potential hazard. Gas under pressure. Corrosive. Explosive. Oxidizing. Hazardous to the environment. Toxic. Carcinogen. Mutagenic. Reproductive toxicity. Respiratory sensitizer. Target organ toxicity. Aspiration toxicity. Health hazard. This symbol shows a person with damage and pertains to chemicals that can cause serious and long-term negative impacts on health. Carcinogens are substances that cause cancer. They are categorized as either natural or man-made, but it is crucial to note that even a small amount of this type of chemical can severely damage human health. Flammables. Pyrophorics. Self-heating. Emits flammable gas. Self-reactive. Organic peroxides. Flammable. The symbol is a flame and it pertains to chemicals or highly flammable gases that may catch fire or ignite once exposed to air or other ignition sources. Irritant, skin and eyes. Skin sensitizer. Acute toxicity. Narcotic effects. Respiratory tract irritant. Hazardous to ozone layer. Potential hazard. This symbol is a big exclamation point and refers to chemicals that usually cause redness, rashes, or inflammation of the affected area. It is also known to pose a threat to public health by harming the ozone layer. Gas under pressure. Gas under pressure. The symbol is a gas cylinder and it pertains to gases that are stored under pressure and may explode if heated or refrigerated, that may cause burns or injuries. Corrosive. Skin burns. Eye damage. Corrosive. This pictogram shows corrosion of materials and skin. This symbol refers to chemicals that can cause severe skin burns and damage to the tissues once contacted with. Explosives. Self-reactive. Organic peroxides. Explosive. This symbol is an exploding bomb and pertains to chemicals that may explode or can cause a mass explosion. Oxidizers. Oxidizing. This pictogram shows a flame over a circle and symbolizes chemicals or substances that under certain conditions or exposure to other chemicals can cause severe physical hazards such as fires or explosions. Toxicity. Hazardous to the environment. The symbol is a dead tree and fish. This symbol refers to chemicals that can cause lasting damage to the environment. Acute toxicity, fatal or toxic. Toxic. This pictogram shows a skull and crossbones, and symbolizes chemicals that even at a very low exposure can cause irreversible changes or mutations to a person's DNA, damage to health, or even fatality. Exposure to hazardous chemicals in workplaces can result in adverse health conditions including headache, difficulty in breathing, skin irritation, severe allergic reaction, and other more serious and long-lasting side effects. Examples of hazardous chemicals in workplace include gasoline, methanol, disinfectants, glues, cleaning materials, detergents, pesticides, paints, cosmetics, welding fumes, heavy metals, metalworking fluids, chemical reaction hazards. As a potential process hazard, The chemical reactivity of any substance should be considered in the following aspects. Its reactivity with elements and compounds with which it is required to react in the process. Its reactivity with atmospheric oxygen. Its reactivity with water. Its reactivity with itself, namely its propensity to polymerize, condense, decompose or explode. Its reactivity with other materials with which it may come in contact unintentionally in process, storage or transport. Its reactivity with materials of construction, namely its corrosivity. Controlling chemical hazards exposure in the workplace. Process industry can't totally eliminate or avoid the use of hazardous chemicals. What companies can do to protect their workers, however, is to follow and observe safety measures that aim to control the chemical hazards in workplaces and reduce their potential negative impact on employees. Some preventive measures and helpful tips on how to proactively maintain a safe working environment include: identify hazardous chemicals in your workplace. Assess risks associated with identified chemicals. Control the risks. Implement efficient control measures. Utilize safety signs and symbols. Perform regular inspections. Control the risks. Elimination. Totally remove and discontinue the use of the hazardous chemicals. Substitution. Find alternatives or replace with other less hazardous chemicals. Engineering control. Implement changes in the process such as minimizing the contact with the chemicals, or physically separating people from them. Administrative control. Implement changes in the way people work such as rotating their schedules or rearranging job assignments. Personal protective equipment, PPE. If hazardous chemicals can't be avoided, or companies can't reduce the contact employees have with them, ensure the use of PPE to lessen exposure and risk factors. Physical hazards involving liquids. Physical hazards associated with liquids are the chemicals that falls into one of the following categories. Combustible liquids. Flammable liquids. Organic peroxides. Corrosive liquids. Toxic liquids. Unstable liquids. Physical hazards involving liquids. Thermal expansion of liquids in closed systems. Freezing of liquids in pipes, valves, etc. Physical explosions which involve two phases, one or both of which are liquids and which are initially at different temperatures. Turnover of liquids at their boiling point in tanks and vessels. A serious hazard in the cryogenic storage of liquefied gases. Boilover which sometimes occurs during oil tank fires. Irregular boiling of superheated liquids characterized as bumping. A safety program includes the following major steps. Risk assessment. To identify the potential hazards arising from the materials and processes involving the use of hazardous liquids and to assess their associated risks, taking into account the adequacy and effectiveness of existing control measures. Safety measures and emergency preparedness. To adopt and maintain preventive measures to eliminate the risks or minimize them to acceptable levels and to establish plans and procedures for emergency response. Hazard communication. To establish appropriate and effective means to disseminate the safety and health information on the materials and processes to employees via adequate instruction and training. Monitoring and review. To monitor the effectiveness of the adopted safety measures with regular review and revision, which may also be required for any new requirements or significant changes in the materials or processes. Electrical hazards. Electrical hazard is a hazard caused by electrical current. The human body can receive an electric shock when the two hands are holding metal objects which have a potential difference, a voltage, between them. More usually, one hand, or another part of the body, touches a metal conductor which is at a potential above that of the surface on which the person is standing. In either case, the current flows by the shortest route, between the two hands, or from one hand to the feet. Physiological effects of exposure to electricity at different currents and voltages. Slight tingling. Shock. Not painful and muscular control not lost. Painful shock, but muscular control not lost. Painful shock. Release current threshold. Painful and severe shock. Muscular contraction. Breathing difficult. Serious burns. Shock. Death from heart or breathing failure. Prevention of electrical hazards. Technicians should be aware of the hazards involved in their work. Self-discipline is essential to ensure that proper procedures are always followed and that the correct equipment, including insulating gloves and mats, is used. There are two ways of protecting people against receiving a shock from faulty equipment. The first is to monitor the integrity of the earth wire connected to the tool, and to cut the supply as soon as it is lost. The second method is to detect the small current that is passing to earth through the affected person and to cut the supply. Explosions and fires. Explosions and fires result from very energetic vapor phase reactions involving high temperatures at which radiation is substantial and usually visible. Combustion is also possible by the direct oxidation of a fuel surface, resulting in glowing or smoldering. The reactions in flaming combustion are usually between a gaseous fuel and the oxygen in the air, but other reactants may also be capable of burning in a flame. The following tips focus on how to prevent fire accidents in the industry. Develop employee awareness. Use a good training program. Avoid hot work at the site. Eliminate the usage of flammable materials. Store flammable and combustible materials properly. Keep a minimum inventory of flammable and combustible materials. Eliminate ignition sources. Avoid explosive atmosphere. Use explosion-proof electrical equipment. Make sure the grounding system works well. Avoid electrical overload. Keep your workplace clean. Dispose of waste properly. Keep fire hydrant and a fire extinguisher in good condition. Perform fire safety patrol daily. Prohibit smoking at the site. Equipment failures. Loss of containment, failures of cranes and lifting equipment and general structural failures occur because of one of 6 main causes. Overstress. Overstrain. Metal fatigue. Brittle fracture. Creep. Stress corrosion cracking. Preventive maintenance should be performed at regular intervals to identify potential problems before they result in equipment failure. Benefits of preventive maintenance include fewer breakdowns, decreased downtime, enhanced efficiency, longer life of assets, improved safety, reduced maintenance costs. The measures used to prevent equipment failures include providing thorough operator training. Providing thorough and routine training will minimize the risk of human error in operating of the equipment, which can lead to failures and even accidents. Untrained staff is not allowed to operate the equipment, where errors may result in injuries, production disruptions and financial losses. Equipment management and maintenance software. Equipment management and maintenance software allows tracking and organizing all of repair and maintenance activities. Mobile apps are especially beneficial for employees, so they can document inspections and repairs, and make notes on the go. Creating and following a maintenance checklist. Create a checklist for maintenance personnel to follow with every inspection. Hazards associated with machinery. The process industry uses different machines including centrifuges, mixers, pumps, etc. Machines can create a hazard of blocking body parts between the moving parts of the mechanism, resulting in cuts, fractures, etc. This hazard can occur during construction, installation, commissioning, operating processes or during cleaning, maintenance or decommissioning. Machinery can also cause harmful effects by emitting toxic or flammable substances, creating dangerous level of noise. Machinery can also produce hot or cold burns, cause electrical hazards, Naturally, the first necessity is to identify the hazard and the risk. And from there we can go on to attempt to make the environment safer by elimination of the hazard, substitution of a harmful substance for a less harmful one, provision of personal protective equipment, staff training, corrosion and erosion hazards. Corrosion and erosion of metals are wasting processes which result in deterioration of the surface of original material. The surface either becomes universally thinner, or more often, it becomes pitted and so thinning occurs in a random manner. The term corrosion applies to deterioration due to chemical or electrochemical process. Condensation of water vapor on metal surfaces and corrosive gases such as ammonia, chlorine, hydrogen oxides, sulfur oxides, etc., can result in corrosion of equipment. The term erosion applies to deterioration due to mechanical forces. Erosion occurs from the mechanical impact on the metal surface of fast-moving particles of liquids, grains of solids, suspensions, gas bubbles, etc. The natural way to reduce opportunities for corrosion or erosion is to protect the surface where the corrosion takes place. For this reason, some process plants are painted or covered in various epoxy resins, or even glass. Process hazard analysis. The accidents on process plants have the potential to result in hundreds of millions of dollars of physical damage, present a danger to employees and the local population, and can lead to significant business interruptions. However, there are measures that can be taken to address accident hazard threats and minimize the risk of incidents as a part of a comprehensive process safety management program. A fundamental element of process safety management, alongside others, is process hazard analysis, a key tool for understanding the process hazards. Process hazard analysis encompasses several techniques to evaluate and control hazards and risk levels respective to process operations to assess the suitability and effectiveness of existing safety measures, and to help determine whether additional risk mitigation measures are needed. Process hazard analysis evaluates the process hazards, any previous incidents that had the potential for catastrophic consequences, engineering and administrative controls applicable to the hazards, human factor that apply to the effective application of safety measures and control, the effect of control failure on the safety and health of employees. Process hazard analysis techniques. Hazard identification, hazard and operability study, hazard analysis, process hazard review, safety integrity level analysis, layer of protection analysis, failure mode and effect analysis. Revision. List types of hazards in the process industry. List types of chemical hazards. Give the examples of hazardous chemicals. List chemical reaction hazards. What preventive measures are used to control chemical hazards? List physical hazards involving liquids. What preventive measures are used to control physical hazards involving liquids? What are physiological effects of electricity exposure? How to prevent electrical hazards? What are the reasons for fires and explosions in the process industry? How to prevent fire and explosion accidents in industry? What are the reasons for equipment failures? How to prevent equipment failures in industry? What are the hazards arising from machinery? Give a definition of the term corrosion. Give a definition of the term erosion. How to reduce corrosion and erosion hazards. What techniques are used for process hazard analysis?